Okay, hello, welcome, good morning, good afternoon, good evening, wherever you're in this world. Thank you for taking time to attend. On behalf of All India Oracle Users Group, very warm welcome to Sangam 20 Virtual Conference, a festival of Oracle. It is already a week 3, day 10 and session 1. Before I introduce to today's
Hi,
keynote
your
speaker,
presentation is not visible.
not visible, sorry for that. Can you confirm, Vinay?
Yep,
Yeah,
it's
go ahead.
Thank you. Yeah, this is what happens if you don't share the entire screen. Okay, uh, welcome again. On behalf of All India Oracle Users Group, very warm welcome to Sangam 20 Virtual Conference. Before I introduce to today's keynote speaker, I would like to cover a brief overview of Sangam 20 and few housekeeping messages. As you can see, Sangam 20 is a 12th anniversary and 12 days of festival. We are bringing the best of Oracle technology to you. It is a 3-week festival and we have 100 plus speakers joining across the globe. We really worked hard to get a new content, new speakers to our Indian Oracle community. We have introduced themes like rapid fire sessions, community sessions, and many more. So please share with your connections. Today we have number of expert speakers are joining across the globe. Do not miss any of the sessions. And again, we are back to database track. I'm sure you love this. Today and tomorrow, it's totally a database topics. So, we are bringing the best of Oracle technology to you. It is your responsibility to share with others, especially with your connections. So this is one of the important slide of Sangam 20. Take a screenshot of this slide and post it in Twitter so your connections also can join Sangam 20 sessions and it is zero cost to attend. Not only that, you'll also make a new connections during Sangam 20. Use hashtags, AIOG or at least Sangam 20. Few housekeeping tasks. We also invite your comments and questions. Please look at Q&A bottom of your screen. Please ask your questions for the speakers at any point of time. Type in Q&A only. Don't use chat. You can use the chat for any support. Um, Again, you continue our conversations and we will upload all the presentation material in the AIOG website. You can access after Sangam 20 conference. And also, since it's a keynote session, we will share the QR code after the presentation, participate and chance to win the gift voucher. And the important thing is provide your feedback at the end of the session. Today is our keynote speaker, Tirthankar Lahiri. I'm sure most of you know and met Tirthankar in our Sangam conferences. And, Tirthankar is a big supporter of AIOG community. But if you don't know Tirthankar, I'd like to read his bio. Tirthankar Lahari is a Senior Vice President of Data and InMemory Technologies Group for Oracle Database. And he's responsible for Oracle Database Engine, including database in-memory, data, indexes, space management, transactions, and data file system. The Oracle timestamp in-memory database and Oracle NoSQL DB. So you can see the portfolio of database. So he's the uh, go-to person for any of your questions on the database. So Tirthankar has more than 25 years of experience in database industry, has worked extensively in variety of areas including manageability, performance, scalability, high availability, caching, distributed concurrency control, in-memory data management, NoSQL architectures, etc. And he has 44 issued and several pending patents in this areas. So think about 44 patents, right? So we are struggling for filing one patent. So Tirthankar has a BTech in computer science from Indian Institute of Technology, Kharagpur, and MS in electrical engineering from Stanford University. So apart from his professional bio, Tirthankar is again, as I mentioned, he's a big supporter of AIoG, and we really enjoy his presence in Sangam conference. Unfortunately, this year we are doing virtually, but still we don't want to miss his session. So here you go. So with that very warm welcome, Tirthankar, please go ahead and share your screen presentation.
Hey, thank you very much, Sai, for that very enthusiastic and warm welcome. So let me see if this works. I've never tried this before. Let me see, where do I get here? Okay, see if this works.
Yeah,
Can everyone see my screen? I'm going to put it in presentation mode. All right,
yeah,
you guys,
perfect.
okay, excellent. All right, you're still seeing the ray in front of my face, right? It's a matter of this lighting in my room. I'll try and reorient my seat a little bit. Okay, all right, let me get started. So I'm going to talk about some guiding principles of building next generation analytic platforms. I'm sure many of you are involved in designing analytic architectures, and I want to give you a few things to think about when you look at the next system you're called upon to design to run high performance analytics. My name is Thankar. I've been at Oracle for a while, and as I mentioned, I've been working in InMemory Technologies for a while as well. So I'm going to really quickly go here. Okay, I'm going to skip the safe harbor here. So before I talk about in-memory, let's talk about some of the motivating factors behind in-memory designs. So the thing everyone wants to be today is to be a real-time enterprise. It's essential in today's world to be real-time. And what does this mean? A real-time enterprise has to be data-driven, uses actual data, metrics based on actual observed data. It has to be agile. It has to respond quickly to changes in that data. And it has to be efficient. So, in addition to reacting rapidly, it should also continuously optimize the big picture for the organization to maximize profits and revenue and basically to drive down costs over time. So, data driven, agile, efficient, these are the three attributes of what a real time enterprise needs to be. And there are many examples. I'm sure many of you are familiar with these examples in today's industries, in insurance, in retail, manufacturing, in financial services, and telecom, in all of these areas. And there's more, even healthcare, especially today nowadays with the whole COVID crisis. Healthcare is another big example of real-time enterprise. In all of these industries, there is a need to very rapidly analyze data and adapt the parameters so that the processes are optimized. And a good example is in manufacturing. It's very, very important to constantly observe the manufacturing qualities to detect defects in time before the products actually leave the shop floor. So manufacturing has to catch any possible deviations in the tolerances or specifications of the end product before the products are actually shipped. There's many examples. I'm not going to go through all of these in detail, but you can understand that in today's industries, in today's world, the difference between real time and non real time basically is a difference between success and failure for a company. The thing that really makes real time enterprises the ideal difficult to achieve is complexity. Now, this is a very, very common sight in India, which, I come from India, so I know this site extremely well, the typical street corner junction box. This proliferation, symbolically, what I'm showing is proliferation of complexity. If you look at today's architecture of many enterprises, there are systems, sometimes multiple systems, many technologies, many components, a lot of heterogeneous implementations that hurt security, administration, and diagnosability. And it basically disrupts your agility and efficiency. And a real example of this is what we call die by do it yourself. So this is a real example of a real company, and they built an architecture with no less than 9 different data engines, for OLTP analytics, data lakes. They all interact through events in many cases, and this has many problems. You have many copies of data. We call it copy contagion. It compromises security. I'm sure many of you must have seen the gigantic hack that happened today or yesterday in the United States. Security is very, very important. And if you have many, many components, your weakest component defines your security, not the strongest component. Just like in your house, the weakest point of entry, the weakest window is what defines your home security, not the super smart security system in the front door. If your back door is weak, your back door is your home security. And this system is very, very complex to maintain. It requires really highly skilled developers and engineers to build and evolve a system like this. So this is sort of the way a lot of people are looking at building systems, and we feel this is the wrong approach. So I'm going to give you a real example. Let's say we were given the task of building a shopping cart application, and shopping online is basically that's what we are all doing right now. I don't know about. I'm sure that's true in India. Certainly in the US, most of my shopping nowadays is done online in this pandemic time. So let's talk about what it might take to build an application that would deliver me products from many stores to my house. And let's call this application Mega Big Cart, let's say. So this is an online delivery application. It has multiple actors. There's customers that place orders, stores process orders. There is a delivery service that delivers orders, and there's an analyst that has to sit on the side and observe business metrics. And the application itself has logic for transactions, for orders and delivery, as well as analytics for both instant decision making and for long-term decision making. So this is sort of the high-level picture of what this app might look like. Now, what are the transactional actions? What does the customer do? The customer spends a bunch of time browsing orders, will build the order, and then finally submit the order. Then the store that receives the order will process the order, ship the order to the customer, and potentially restock any products that are running low in inventory. And the delivery service will have to schedule deliveries, pick up from store, deliver to customer, etc. So these are the traditional transactional actions. Okay, so this is like a high-level view of what this application looks like. So what's the first thing we do as someone developing this application logic? We'd first define the tables and relationships. We'll have a customers table, an orders table, a table of items carried by each store, a table of stores, then the active deliveries, products, and inventories. Okay, so this is a pretty simple classic ER diagram. Customers have multiple orders. An order contains multiple items, and in this particular architecture, I'm assuming that one order is attached to one store, so one order can't span stores. An item is part of a delivery once the item is part of a fulfilled order, and it obviously an item refers to a certain product. A delivery can contain multiple items. Some very large orders might be divided into multiple deliveries. So a delivery is really a subset of an order. And it's typically it's from a single store to a single customer. And then the store must maintain an inventory. So for every product the store carries, there has to be an inventory of the product. So we have an inventory table that's many to many that basically maps stores to products and product inventories. Okay, so this is very simple database 101 stuff. Nothing fancy here. The thing to remember is all of these relationships and all of these primary keys correspond to indexes. So each table here is a primary key, the customer ID, order ID, items ID. Each foreign key has an index. So the reference from a store to an order there is a corresponding index on store ID in the orders table. So each of these columns that denoted in red and black, have transactional indexes. So now we can get this application up and running. We have the simple schema, we have some indexes, we have the operational database, and now it's not difficult to see how this application can be built very simply with the customer, store, and delivery service actor performing these simple transactions on a very simple underlying architecture. So far, so good. This is a very simple system. No problem so far. Now, what happens is, we need to do more than just transactions. Because often just to run a transaction, I will need to run some analytics to decide what to do with my transaction. So before I buy something, if I say want to buy a phone, the first thing I do is what is the best phone out there, the top rated phone? and which stores carry it in my region that can deliver to me. And then if I do buy such a phone, what else do I need? Because I always lose my charging cables, so I typically always buy multiple charging cables for any phone. So all of these questions are asked before the customer can place such an order. Now, when the store receives an order, the store has a very short window of time to try to get more business from the customer. The store could say, look, you're buying a phone. Maybe you need to buy a battery extension pack or something. So the store might have to, try to offer promotions to the customer based on what the customer has ordered and where they are located. Likewise, the delivery service might also want to find out, hey, when I'm given a delivery request, can I do more than just that one delivery? Because the more I can combine into one delivery, the better off I am, the more efficient my business is. And then also I want to find out if I have a long list of deliveries to fulfill, well, how do I prioritize that list? I need to find the store and the customer with the most pending deliveries and prioritize those. So all of these are sort of real-time analytics that need to be answered before a transaction can actually be processed. Now these queries, if you look at the schema I had before, I didn't have indexes that made these queries fast. These queries would actually run quite slowly. Now to make them run fast, what typically you do is you take the columns on which you might have real-time analytics and you index those columns. So in blue, literally every other column in the schema, you might have analytic indexes on. For instance, if I want to find top rated products, I need an index on the rating column in the products table. So, and if I want to find top rated products in a certain category, I need rating index on both category and rating. So you see what I mean? You have to add more indexes to get good performance from your application. So it's still a simple application relatively, but now I've added this blue pile of indexes, which does have some overheads. It increases the database size, first of all, because now the database has indexes for OLTP and analytics. It slows down transactions because each transaction that updates these tables has to now maintain these blue indexes. And the other problem is you have to know what the real-time analytic operations are in order to index for those operations. So you have to anticipate the future, which is sometimes tricky to do. So, and then we're not done yet, by the way. So, you thought real-time analytics is everything. It's not, because there is something else that needs to happen also. There is a need always to look at business trends and to see what other things should be done to optimize the process over time. So for instance, analysts might want to know which products give us our highest margins. Maybe we should, sell more of those products. Which are the best stores to distribute a certain product in a certain region? And then, what if I were to offer a discount on some item, like flour was very popular in the pandemic in the US? How much could that improve our margins overall? So these are questions that need to be answered in order to get better performance over time for the business as a whole. Okay. Now, these queries actually look at a lot of data, right? So these are not short-running queries running on the operational data. These look at historical data. And typically, it's a really bad idea to run these queries on your operational database because the data volume they access. So what typically happens is that you create a reporting database instead, which has a different schema. It no longer has your 3NF OLTP schema, the normalized schema. It creates a more denormalized star schema. And in our example of Megacart, there's a central table of sales, and the sales table has a number of dimensions like customers, stores, and products on which you can run various analytic reporting queries. This schema is, again, different from the original schema. So the data that you get from the original schema has to be transformed to meet this schema's requirements. And every single column, almost every column needs to be indexed in this example schema. So now what I've done really is I have doubled the complexity of my application. I now have the operational database on which I still have analytic indexes for the real-time responses I need. I've also added a reporting database which has star schema and a set of star schema indexes. And these various actors now have to work on two different databases. So if a customer or if a store or delivery service needs to access reports, it has to go to the reporting database. So this creates more complexity for the overall architecture. But this is pretty standard practice when designing large applications to separate the reporting into a different database. And this isn't sufficient, by the way, because one more thing that people often want, and every one of these actors need to have what we call dashboard queries. Every time you log in, typically into one of these sites, you'll get a dashboard showing what your historical activity has been. Like for a store, for instance, what is your total sales for the year? What is your growth over last year or last quarter? What are your top selling products? So these are repetitive queries with the same parameters issued over and over again. So dashboard queries are another fact of life. Now these are run quite often. Oftentimes they're run at some maybe at login frequency or at some periodic interval. They are resource intensive, and what you don't want to do is to recompute the result each time. If my year-to-date sales, it probably is okay for me to give you my year-to-date sales at a slightly delayed rate. I don't need to keep that up to date continuously with the most recent sale, because each incremental sale makes a very small difference in the total amount. So what typically people do is they create pre-computed summary tables, like materialized views, for instance, or cubes, where instead of having to recompute the query result, we summarize the result in these summary tables. So like quarterly sales by store, monthly deliveries by store, top 10 products in a store by month, are summaries that are maintained by a summary refresh inside that reporting database. So materialized views are the way we do this traditionally. So now look at my poor megacard application. I began with a single database with a single set of indexes. Now I have no less than essentially 4 different sets of indexes, 2 copies of data, star OLTP data, star schema data, and the summary data as well. I have extract, transform, load operations to the reporting database. I have the refresh of the summaries on the reporting database. So there's a lot more complexity now suddenly. Suddenly I began with a simple goal of keeping it simple. Now I have anything but simple. This is complicated. So what is the complexity here? The reporting database itself adds a lot of complexity. I began with a single OLTP database. Now I've got a new database to manage. It requires complex ETL. The analytic indexes add overheads because they slow down my operations, they increase database size, and they need to be defined in advance. And the pre-computed summaries add complexity because typically they lag their source tables, they're not up to date, and they also increase the database size and add additional overheads to maintain. What we really want, honestly, is this. We don't want anything else. We want everything to run on one database, ideally. Which you could of course scale the database out as needed, but we want one database, one source of truth on which all operations are running. We shouldn't need reporting databases unless you're aggregating from multiple sources. And if you have a good operational database, you shouldn't need multiple sources. We shouldn't need predefined index analytics. We shouldn't need pre-computed summaries. And basically everything should run on the same database. The question is this possible? A lot of folks will say, no, it's not possible. You have to create multiple databases. You've got to create multiple data copies. You have to create multiple sets of indexes. And so the question is this possible? Now, I wouldn't be asking you the question if it weren't possible. So the answer is yes, it is possible. And what makes it possible is database in memory. Now, database in memory starts the basic premise that there are 2 different ways of storing data. Row format data is ideal for OLTP because all your transactional data for a row is stored together. It is not great for analytics, which scans many values in the same column. That's why there's also a column format for data, where all the column values for a given column are stored together to make it much faster to process data for analytic processing. So database in memory takes these 2 formats and combines them into a single dual format architecture. What happens is this creates a row format for transactional processing and column format for the same data for analytic processing. Transactions use this highly concurrent row format, which gives you tens of millions of transactions per second. And the analytic operations use the highly optimized column format, which uses vector processing to give you billions of rows per second scan speed. So it's a very, very fast format for analytic processing. The in-memory column format is purely in memory. It's in memory only, which makes it easier to maintain because there's no disk access required to maintain it. So There is no logging, no transactional overheads to maintaining this in-memory column format. It's available everywhere, and because it's built into the Oracle database, all the features of Oracle database like security, HA, data guard, they all work transparently. It can be enabled for only the hot data. You don't have to do it for all data. You do it for the data that you need real-time analytics for. So you can subset the database that you want. You can subset the database in any way you want, and use in-memory for basically hot tables or hot partitions or hot subpartitions. The fundamental thing that makes in-memory fast is what we call SIMD, single instruction multiple data vector processing. It's actually a very old technique in CPUs. It was originally invented for graphics and supercomputing, but it's actually been very useful for database management as well. So if I'm looking for all the sales in the state of California, I just simply look at the column vector for California, and then scan it, and then I can vector compare those values to California in essentially one cycle, which leads to very fast performance because I'm multiplying the performance by the number of entries in the vector. And these techniques give us the ability to scan at the rate of billions of rows per second. And no matter how good your row format is, you'll never scan at more than millions of rows per second. So again, just a quick summary of in-memory. I'm not going to go through this in a huge amount of detail, but feel free to reach out to me privately if you want more details. But in-memory, in a nutshell, is there is a column format that lets you, first of all, filter the data by only the columns you need. There is SIMD vector processing that essentially lets you process multiple values in the same instruction. The column store is also divided into these units. We call them in-memory column units. And each unit basically maintains a storage index that let you eliminate unnecessary units to visit. So if I'm looking for the value 9, I know that I can skip looking at the units on the top and the second unit. And it's only the third unit that I might need to look at because the storage index says it's only possible to have it in that unit. And of course, all the data in the column is compressed. And because the column values are from the same domain of data, the compression typically is very it's very successful and very complex. You get a good compression ratio. So again, just quick summary. In-memory gives you much faster processing for all aspects of analytic queries. I already explained why it's fast for scans, because you basically scan using vector processing. It also speeds up joins. Basically, traditional join processing, you have to match the values between these two tables. What happens within memory is you can very quickly filter the large table for values that may match values in the small table. We call this Bloom filter. It's actually an old optimization technique, but it works really well on the for in-memory. So in this example, if I'm looking for products for a certain type, I can build a Bloom filter of those products and use that to process the rows in the sales table and very quickly eliminate the rows that won't qualify in the join. Again, I'm not going to go through this in detail, but this is a high-level concept that essentially what in-memory does is it replaces joins with fast column scans. Now, this extends to reporting as well. It's not just joins. With reporting, where I'm looking at multiple tables, multiple dimensions, I can use the same trick. Use in-memory to quickly filter and reduce the data I need to look at, and then do a report generation in real time by scanning the fact table. Now, this I will spend a little bit of time on because this is a very cool, cool optimization. So let's look at this example. I want to find the sales of swimwear products, swimming costumes, goggles, etc., in California. Let's say that's my query. I want to find total sales of all swim products in stores that are based in California. So the first thing I do is I scan the products table looking for things that match swimwear, and I look for the stores table and look for stores in California. And I build this, in this example, a two-dimensional matrix of the qualifying products that are swimwear products and the qualifying stores that are California stores. Okay, so each of these combinations has a corresponding cell. Then I scan the sales table, and if I find that in that sales fact table, my store and product match one of these cells, then I just increment the corresponding cell by the amount of that sale. So look at what happened. I converted what would have been a very complex aggregation and join into 3 scans. So I did a scan of the products table and the stores table, and I got this outline. And then I scanned the sales table, and I managed to produce my aggregation by updating all the values in the corresponding cells. So my report now runs massively faster because I no longer need to compute the join and compute the aggregation. In addition to accelerating analytic queries, InMemory also makes mixed workloads like Megacart faster. As I said before, analytic indexes are a massive pain because they slow down the workload, they make the database bigger, and they only work for queries that you have the indexes for. If you can't tell the future, then you're out of luck. If you get a query that doesn't have the index, sorry, you're not going to get good performance. So what you can do with InMemory is replace these with the column store. The column store is not a persistent structure. It's not stored on disk, so updating it is fast. And because you have it on all the columns of the table, you have fast analytics on any column. You don't need to anticipate the workload anymore. And because there are no analytic indexes, your database size is reduced. So none of the drawbacks of analytic indexes, but all of the advantages. You get fast queries without overhead in space, without the overhead of transaction management burdens, and without the need to know the future, because knowing the future is something that only a few people can do successfully. Sai is a good example of someone who can tell the future. I am not. So in my case, I need an in-memory column store that covers all my columns. I think Sai is smart enough that he can predict the workload and build indexes, but most of us are not like Sai. We have to know, we have to assume that we don't know the future, so let's build a data structure that works for all workloads. The other thing is, InMemory is simply not limited to compute. On Exadata, which I think many of you are users of, InMemory is also pushed into the storage tier. So in addition to InMemory in DRAM, in Exadata you have InMemory on flash, which actually has a huge advantage. It means that you can get the same benefits from InMemory on your offloaded smart scans. This gives us a massive increase in in-memory column capacity. I think it's of the order of half a petabyte of flash on a full rack X8 Exadata, which means that now I can apply in-memory to tables that don't fit in memory. If my tables are too large or I have too many tables to mark in memory, I don't need to declare them in memory on the compute. I can use in memory on flash and get the same benefits. So look at the benefits here. I know what I said previously was in memory basically replaced analytic indexes. Flash in memory or in flash memory replaces the need for a reporting database, because now I can run those longer term analytic queries on the in-memory column store in the storage tier. So it's a very, very cool feature of Exadata with database in memory. And database in memory has been actually it's a very actively developed technology. We've been working on it for a while. Actually, we have released it in 12.1. Most recently, you might have seen the 21C announcement. Actually, I should have made this 21C. My apologies. 20C was a preview release only for the cloud, but 21C is what you will actually get very soon. 21C has a number of innovations in memory. We've actually added a number of things to allow in-memory to work, not just relational workloads, but also for other types of workloads as well. So a very long history of very active innovation in this technology. The thing that in-memory does, and I mentioned this in the abstract, it's much more than just making things faster. Imagine when air travel became possible, when you could fly from London to New York, it didn't just mean faster travel. It actually changed everything. Society was transformed. Suddenly business, trade, politics, education, media, sports, defense, you name it, every single aspect of society changed because of air travel. Because I think the fastest Atlantic crossings would still take 5 to 7 days. I think some of the fastest ships were able to do it in 5 days. But imagine the difference between that and taking 7 hours to go from New York to London. And of course, again, eliminated seasickness. You do have jet lag to contend with, but not seasickness. So there are some other advantages. So again, database in memory or in-memory designs do not just improve performance. Because you can get results instantly, you can take decisions much more quickly. Because you don't need additional systems, additional indexes, you have lower costs. And this lets you do what I said at the beginning. More important than performance is simplicity. You get a simple and more agile enterprise architecture using in-memory centric designs. That's the key contribution. I do think in the next 10 to 15 years, there's going to be a complete rethinking of analytic data platforms, and you'll find in-memory technology is going to be central, front and center of next generation analytic systems, just because of the simplicity it brings you, more than the performance, the simplicity, the elimination of tiers, the elimination of redundancy. So what happens now? Do I actually get simplicity with my megacard application? Yes, I can now run the entire workload on the operational database. The in-memory column store replaces my analytic indexes. I don't need to have analytic indexes anymore. The in-memory column store is sufficient to run analytic queries for real-time reporting. For my data warehouse or reporting database queries, I can use the in-flash column store. If I don't want to use in-memory for those longer-term reports, I can use the in-flash column store to get high performance for the longer-term business process optimization queries. And I did mention to you this really cool in-memory reporting trick that we have for database in memory, the thing that does reports through multiple scans. Well, that replaced the need to have pre-computed summaries. Remember in Megacard, I had these summary tables to run these dashboard queries. I don't need those anymore because my in-memory reports can run directly on the source data as fast as I would be running had I created a summary table. So now what I've got is really the holy grail. I've got super fast transactions, really fast analytics that runs against all the data. I don't have to know my workload in advance because I can just declare in memory for all the tables, and now all the analytic queries run really fast on any data. And with in-flash columnar, I don't need to worry about memory capacity. I can offload any query I want to flash and have it run at the same in-memory speed using the flash tier in storage. This entire thing now runs on one database. Now, if I need to, I can scale this database out. An Oracle database has a lot of scalability technologies. We have rack, we have multi-tenant, we have partitioning, we have sharding. So there's many things you can do to the Oracle database, but still, logically, it's one database, which is much better than keeping a plurality of databases. One database instead of multiple databases. Now, in-memory is a very popular technology. It's one of our hottest offerings from Oracle database. It's used widely in many industries. Um, you know, there are many examples of in-memory being used for both mixed workloads as well as for reporting use cases. One of my personal favorites is Lufthansa. I think I might have mentioned this in Sangam a couple of times, and I apologize if I'm repeating this for those of you who've heard this, but this is the use case that I'm sort of, it makes me very happy and proud because I used to fly a lot before the pandemic, and I often flew through Frankfurt Airport. And Frankfurt Airport had a gigantic aircraft hangar where Lufthansa basically would do repair work or maintenance work on aircraft for many airlines, not just Lufthansa airlines. What used to happen was this process of taking the plane apart and reassembling the aircraft. There was something called a D-check. That process was extremely time consuming and it was a logistical nightmare. Because the plane basically had to be taken apart completely. Imagine a gigantic Airbus, whatever, the Airbus A380. That aircraft, honestly, every single part would be refurbished, inspected, and then put back. And the analytic queries to decide what the refurbish schedule should be were actually bottlenecks for this entire process. So they adopted in memory. They found that data ingest performance went up significantly. They could actually absorb more events much more quickly because there were no more analytic indexes. And the analytic queries ran 100x faster because of this improvement in performance because of in-memory processing. So that's a very nice use case. If you ever fly through Frankfurt again once the pandemic ends, and if you see this giant aircraft hangar by Lufthansa Technik, you'll know that in-memory is hard at work inside that hangar. Again, many other use cases that are very similar. AT&T Wi-Fi, same deal, that they use in-memory to process reports much more quickly. this ran on SAP Business Objects, and they found that the entire application ran much faster using in-memory. Lots of applications involving complex OLTP applications as well as warehousing applications. The other thing to think about is when applications evolve, right? So they typically don't stay pure relational forever. The applications can become more demanding in terms of semantics and data models. So sometimes you may need to do spatial data processing or graph processing, etc. Even in the megacard application, I might need to do spatial data processing to find customers in a certain geographical region or delivery service drivers who can operate in a certain geography. So, the need is eventually to add more data models to your application. That happens. It's just natural. So one approach is to do this, that you can create a separate database for each type of workload you need. So if you want to run map workloads, you can create a map database, copy data from the OLTP database there, run the map analytics there, and send the results back. This is one approach. It's the approach I showed you in the early slides of this example architecture, which has many, many copies of data. The thing is, you don't need to do this anymore. Oracle database is now a converged database. It lets you run many, many data models against the same data. So instead of moving the data, you can move the algorithm into the database. You can run spatial algorithms, you can run graph, you can run machine learning. All of these things run natively inside the Oracle database. The data stays in one place. And you can run spatial analytics, you can run document store analytics. You can view the world as relational or as JSON. They both work interchangeably. And you can run machine learning models. You can train your models and do inferencing with Oracle's own portfolio within the database. So this again gives you simplicity. You have the same security policies against all your data. It prevents this what we call data fragmentation, where the data is divided between multiple units. And even worse than fragmentation is what we call copy contagion, where copy contagion really is a disease where I can no longer run analytics consistently because each database has a different piece of the same data. And then also this whole business of integrating data from multiple sources, that is complicated. It requires message buses. It requires integration frameworks. It requires ORM tools. All of these things add complexity and hurt performance. So having a single database avoids data movement, eliminates all of these other complexity sources. So converged database is really the final icing on the simplicity cake. To make it very simple, use converged database, not a dozen different databases. And that one database can run the entire workload. The ultimate in sort of the converged database journey is Oracle's new autonomous database platform. It is the world's first truly self-driving database. It scales out with fault tolerance and DR. It runs on this best-of-class, best-of-breed enterprise proven platform, Exadata. And it is fully compatible with existing enterprise databases. It is self-securing, so everything is encrypted by default. It hides sensitive data. It applies. You can't miss a security update. It does it automatically. So that's a very important thing to prevent any security breaches. And it's self-repairing. It recovers automatically from failures, provides very high uptime, and elastically scales computer storage as needed. So it's a really, really, really powerful converged data platform. I do not know if anyone has tried this yet, but I would recommend the Oracle free tier for trying out autonomous database. And I've done this myself. It's a very, very simple thing to use. You can literally get an Oracle database up and running in less than 5 minutes if you go to the free tier. So this is the example page. You go to the OCI free tier login screen, and you can go ahead and create yourself an autonomous database or autonomous data warehouse database. And then it's step by step. It's very simply explained as to what you do next. So you can go into your autonomous database, which I just did fairly recently. You can go there. And then the beauty of this tool is you don't even need to actually create database connections. There is an option to create database connection from your desktop to the cloud database. You don't even have to do that. You can just use SQL Developer Web directly and get started with it. So it's a very, very simple way to get started directly with your with autonomous database. Okay. I see there are some questions. I'll take them after. I'm almost done, so let me finish my talk and then I'll answer the questions. Okay, so just give me a second, and how do I put the screen back in a second here? I want to just get rid of the screen so I can focus on my talk. But I'm almost done. I'll answer the question after that. Okay. But yeah, I would recommend trying the OCI free tier out. It's extremely easy to use. For those of you who actually had to, actually really deal with Oracle installations and Oracle bring up on premises, you'll understand how much simpler this new, the cloud free tier makes it. Okay, so again, complexity is evil. Complexity is a curse. Complexity is an innovation barrier. And I wanted to conclude with a quick thought that I've seen this before because I have many friends who are on the other side of the fence and actually are Oracle database users and administrators and DBAs, and I've seen that there's basically 5 stages of complexity. The first stage is denial, where you have this extremely complex system like the one on the right, and you'll say it's actually very simple. And I know many electricians in India will say, well, that's a very simple junction box. I know exactly which wire to fix if your light doesn't work. Okay, so I call that denial. When you look at that and say, yep, it looks simple enough to me, who said that was complicated? The next thing is pain. The next stage is pain, because when this thing breaks, then you actually go figure out which wire is broken and which plug you have to unplug. It's painful. So that's the second stage, is pain after denial. Denial lasts for a fairly long time, by the way, but inevitably denial gives way to pain. I've seen that over and over again. After pain, once the pain is relieved because you fixed the problem, the next thing that happens is you get anxiety because you believe, yes, I fixed this problem, but I think it'll break again very soon. It's not going to be fixed forever. So when will it break next? Then if this happens a few times and you go through these stages, eventually what happens is you get depressed, because it always breaks. So, life is horrible. My life is never going to get better. Depression is the next stage. And of course, depression can lead to substance abuse. Now, I'm not saying I've ever witnessed that myself, but I'm guessing somebody who's depressed long enough will eventually start abusing substances to find relief. So the question is, do we want this? The answer is no. Please just say no to complexity. The thing is, avoid it. Do not go down that path. And there is a famous quote that simplicity is complexity resolved. So think of InMemory not just as a performance technology, but really as a simplicity technology. Can I eliminate moving parts? Can I make my architecture simpler by getting good performance reliably without having to pre-create structures or create additional databases? There is a ton of information out there available, but I'm going to leave this for you guys to screenshot if you like, or just take a picture of. You can try out all of these things whenever you feel like, just to get some more information. You can start with InMemory using Oracle Database Express. There is an 18C Express right now. It's going to be upgraded to the more recent release, but right now it's 18C, and you can use this on your own machines with up to 2 gigabytes of in-memory column store. You can try out Exadata Express in Oracle Cloud. That gives you up to 5 gigabytes of in-memory column store for free. And in Oracle Database Enterprise Edition from 19.8 onwards, the in-memory base level gives you a free column store of up to 16 gigabytes. Now, this is great because you can enable this column store in production, and you don't need to buy the in-memory option. So 16 gigabytes of column store per database instance is available for free if you are using the in-memory base level. And you can, if you take a screenshot or a picture of the slide, if you go click on that link, I just made these convenient links for you to look at, so that, because the links otherwise are too long, you can go click on the links and see how to enable base level in your systems. For information, you can go try out, look at the in-memory blog. We have a lot of useful information there. Again, please take a picture of the slide if you can. The product and technology is described in a lot of detail in this white paper. It's the link is here, as I mentioned. And of course, last but not least, try out Autonomous Database. Give it a test drive. It's free. It's easy to use. You'll find it miraculous that Oracle Database is so simple to use. It's like, within 5 minutes, I can write really complex applications and do meaningful work without the burden of having to download, install, configure the database. So autonomous database free tier is actually a fantastic new technology. I would encourage all of you to try it out. And I think that's all I have to say from my side. So let me just take a quick look at the questions that you might have asked in the meantime. So I'm going to say, so Samir has asked, what is the RAM requirement for in-memory if the table size is more than 500 gigabytes? So let me see. I haven't used the Zoom thing before. I'm going to try to answer this live. Do I click on this or does someone else do it? All right. Okay, so there's a couple of ways to think about this. So your table, first of all, maybe more than 500 gigabytes, but in-memory does compress the table. The only way to know how much memory you need is to use the compression advisor. You can use the compression advisor package, and it'll tell you what the estimated in-memory size space requirement is for a table of that size. And if it turns out that you think the table is too large, then the next thing you could do is you can try to use you can try to partition the table and then see if you can load separate partitions of the table into memory. But it's hard to say exactly how much you need unless you run the compression advisor, because that result is very data dependent. So some data compresses very well, some doesn't compress as well, so it depends on the data. Okay, so that's for Samir. Samir has another question, which is in-memory on prim. Can you is Samir on the call? Can you clarify what prim means? I didn't understand what he meant here.
I think it's on-prem premise.
Oh, on-premise. I see. Sorry, I didn't read this. Yeah, it's the same technology. It's no different. You know, I read a funny quote somewhere that there is no such thing as cloud. It's just somebody else's computer. So it doesn't really matter. In memory is in memory. It doesn't matter. In memory on premise on the cloud, it's the same thing. Same algorithm, same technology, just running in a different place. Okay. Mudit has a question. Converged database features available from which DB version? Any special license? Excellent question. The answer is Oracle has always been a converged database. Okay, it's not that there's any special version from which Oracle suddenly became converged. We realized that we need to draw attention to our capabilities. And this is the only thing new here is the term, it's not the concept. Oracle has had machine learning for a long time. JSON has been the data since Oracle 12c. So, and I believe none of the converged features today require a special license. We used to require a special license for analytics and spatial and graph. We don't anymore. Those options are now zero cost. As of actually, it's been zero cost since last year. So there's no. I don't think any of the new algorithms or data models require any special special license. Okay, so that's from this question. Good question. Then Aishwarya had a question on in Oracle RAC. Is there any inbuilt fault tolerance for the in-memory column store? Okay, this is a good question. The answer is there is built-in fault tolerance. However, it is available only on Exadata and on Oracle Cloud. What we do is we have in-memory duplicate on Exadata and on Oracle Cloud, which lets you keep multiple copies of the column store on multiple nodes in the cluster. But it is a property of Exadata, and it is also available certainly on our cloud services. Okay, then the next question was from, I apologize, I'm guessing the first name is Pothuraju. Is there any possibility of extending the free tier account period for 60 days with the same dollar limit? Okay, the free tier is free. It's always free. It never goes away. The cloud, I think what you're talking about, the cloud credits, not the free tier. The free tier is always free. You don't need to ever worry about it going. By the way, I have a free tier account, which I have created as a non-Oracle user, just to see how it works for the end user, for the developer. And I created it like 6 months ago, and it's still active, and I can still go up there and bring up my database whenever I want. The only thing is, if I don't use the database for I think 2 weeks, then it just shuts it down. But bringing it back up is very quick because it's basically a PDB or a tenant in a multi-tenant database. So it's not like full database startup. It's like bringing up a tenant. So it's very easy for us for you to use, basically get the free tier benefits without having to worry about this 60-day expiration of credits. Okay, so then the answer Suraj to the question. Since many customers are not, still many customers are not yet starting to use 19.8, do we have any plans to backport the in-memory base feature to versions like 18C, 12.2, etc.? Okay, the answer is unfortunately no. And the reason is as follows. The base level really is actually a 21C feature. 19.8 is already a backport. So we did backport it to make it available. And we fully expect 19.8 to be the place, or 19C rather, to be the place customers upgrade to very soon, because 11.204 is rapidly reaching end of life. Backporting this is actually very difficult. We were able to do it 19.8 with some difficulty. Going back further would be very tricky because we'd end up, hurting sort of the rack rolling requirements of backports. It's very difficult to add, parameters and levels in early releases. So right now there's no such plan for it. But 19.19c is where everyone's going. I mean, I'm certain that many customers here today are looking at 19c either today or it's on the roadmap to adopt very soon. So it's coming definitely. So just have patience. Once you get there, you'll get it. Okay, then question from Pawan. Very, very good question from Pawan. Does InMemory give benefit for JSON columns? The answer is yes. InMemory, actually, I didn't mention this in my slides in detail, but InMemory has a massive benefit for JSON. What we do is if you have a JSON column that you put in the InMemory column store, we store that column in the memory column store in a highly optimized binary format. And we actually decompose that column into its attributes. So if you have a JSON, like a document with multiple attributes, then each attribute becomes a separate in-memory column vector. And you can imagine that you get much better performance scanning those in-memory column vectors of JSON attributes than scanning text JSON documents. So the answer is yes, there is a huge benefit. In 21C, which is not yet available on premises, when it's available, you will find that there is a native JSON data type on which InMemory has even more benefits. So there's a lot of value from InMemory and JSON. Those two technologies work really well together. I hope that answers your question. These are all very good questions, by the way. Very happy to hear that these are all relevant and very well thought out questions. Does anybody else have any more questions? I still have 3 minutes, so I'm happy to take a few more if anyone has any. Does anyone have any? If anyone has any other thoughts, compliments, criticisms, that's also fine. I prefer compliments to criticisms, but I'll take criticism too if it's constructive. So.
Yeah, please. This is the right chance to ask Tirthankar. Please post your questions in the Q&A.
And I did put this on my slide initially. I am on Twitter. Twitter handle is DB InMemory. Feel free to follow me there, and I'm happy to answer questions. Later on as well if you want to reach out to me directly. I'm happy to do that. But I'm very happy, by the way. All of these questions I answered today are very, very good questions, and frankly, it shows people were paying attention and were interested in the technology. Sai, any final thoughts before we wrap up? Oh, good question. Does the base level feature work with Active Data Guard? That is a good question. I do not know the answer to that. I believe not, because of the reason. I have to get back to you. Actually, that's a very good point. I don't know the answer to that. InMemory on Active Data Guard only is available on Exadata. So that's step one. Now, it's a good question as to whether the base level is available as well on Exadata. I don't know the answer to that, but I have to get back to you. So if you can shoot me an email, or if you would, follow me on Twitter, I'm happy to answer offline. And Sai knows where to reach me. If you have any questions, you can always find me through Sai. Can in-memory option be used for eBusiness Suite on 19.5? eBusiness Suite is a very complex application. There is nothing preventing you from using in-memory on it. It's just that you have to be careful as to what you enable. So again, it depends on which modules. I know that there have been some whitebooks presented by the in-memory cost management team, and they certainly use in-memory actively for that module. But for other modules, you have to look at you have to get guidance from eBusiness Suite support or development. Okay. Was there any other question? I thought I saw one more. Wondering let's take one final question, Sai, that's okay. wondering with such massive in-memory speeds, bad queries will get missed to get tuned. If your query runs fast, who cares, right? It doesn't matter. To me, a bad query is only bad if it runs forever and blocks other people. If every single thing runs 100 times faster, no one cares. Now, in reality, you will find that in-memory helps, some queries, and some queries it doesn't help, depending on where the query is spending its time. If the query is bottlenecked and other things, in-memory is not going to be a big benefit. But I don't think this will be an issue. If anything, in-memory will magnify the difference between a good query and a bad query. You'll find that good queries run really fast and bad queries run much slower. So it'll actually make the gulf even bigger. But that's a good question. I think, Sai, we're over time, right? So any other final parting thoughts, or I think we can call the day.
Yeah, thank you so much for taking time, your valuable time, and spending time with us. As always, it's a privilege, have you in. I think it's virtual now, but we are really missing the face-to-face interaction, and definitely we want to see you in Sangam 21. I think you should
book. Is it
book.
in Hyderabad or Bangalore? What's the plan right now?
So last year it was Hyderabad, so we'll go back to Bangalore, and
Okay.
yes, absolutely, we want to see you.
Yes.
And I think, guys, a lot of information Tirthankar shared. So let's try, if as Tirthankar mentioned, you can see his Twitter handler here, Twitter address here, DB in memory. Ask any questions, right? So that is one of the best thing is, ask questions in the Twitter anytime, or when you're facing any problem, right? But don't ask any SR questions because it'll be complicated.
But yeah, I put my Twitter handle and my email address. So if you want to reach out to me, please feel free to do that.
Yeah,
Thank you very
absolutely.
much.
So once again, thanks for everyone attending this keynote. Hope you enjoyed. And also Tirthankar, thank you very much for your valuable time.
Thank you.
And good night for you and good day for everyone. Thank you.
Sure. Thank you. Thank you. Bye. Bye, sir.
With that, we are closing this session.
Okay.